formula. It's h equals negative 16t squared plus v sub o t plus h sub o. This represents the height of an object when it's thrown upward, downward, or dropped. Now, the VO is going to change based on, it's going to be positive if you blast something upward. If you blast something downward, it's going to be negative. And if you simply drop it, like you're not pushing it, you just drop it, it's 0. Okay? So, you got to read the problem and know what they're doing. And in this case, they're blasting something up at a velocity of 160 feet per second. So if it's blasted up, V sub O is going to be positive. So what you're going to do is you are going to substitute 160 in for V sub O. Now, what is H sub O? This H sub O is where is the object when you blast it or throw it down or drop it. If it's on the ground, H sub O is 0. So where is the object when you blast it? What's the height of it? So if you read this problem, it tells you that you're on the ground. So how high is the object if it's on the ground? What's the height of it? If it's on the ground, it's 0. So this height is where is the object, H sub O. Where is it currently when you blast it up or blast it down or drop it? This H is the height you want to find when it reaches. So after you blast it or drop it or throw it, I want to know the T value is when. When will it reach the ground? When will it reach 100 feet in the air? When will it reach 200 feet in the air? So this H is the height that you want it to be, the time that you want it to be at. So if you read this problem, you are going to blast this, what are we doing, a rocket? A rock is blasted upward at a velocity of 160 feet. At what time will the rocket hit the ground? So this is the ground. So this is what you have now. You're going to substitute 0 in for H. And the velocity is 160, so time. And the object is on the ground. So this is where the object is, and this is when it's going to hit the ground. It's going to change. So you're going to play around with these three variables right here. Everything else stays the same. Now, how do you solve this by hand? This is factorable. We can pull out, you don't need that. You can pull out a negative 16t, and you're left with t minus 10 if you were to do this by hand. And now the 0 rule says if you're going to set each of these equal to 0. So t is 0 and 10 is 0. What does this mean? So here's your rocket. This is the height. You're on the ground. You're going to blast it up, and what's going to happen is eventually it's going to come down. This is time. So think of this as like your x. This is your x-axis. So when will it reach the ground? This is when it's going to reach its highest point, and this is when it's going to reach the ground. So what are these two answers? When will it reach the ground at 160 feet per second? In 10 seconds, it's going to land back on the ground. Now, why are there two answers here? Because when will it reach the ground? It's on the ground at 0 seconds, and then it's going to reach it again at 10 seconds. Now, if you type this in your calculator, you will see 0 and 10. You may have to change your window, though. So zoom, if you want to play around with this right now real quick and make sure you understand 0 and 10. But 10, at 0 seconds and 10 seconds, that's when it's going to reach the ground. Anyone have any questions? So this will help you do problems 21 and the back side of that sheet that I gave you the other day. Okay, number 7 is easy. This is a mixture problem. We've got a coffee shop, and there's 2 kinds of coffee. You know what? I'm not even recording, am I?
Yeah, you are.
Yeah? Oh. We have 2 kinds of coffee. Brazilian and Turkish coffee. And we want, what's the quantity that we want? We want 300 kilograms. So we're gonna take Brazilian coffee and Turkish coffee and we wanna mix them. And we want a total of 300 kilograms. So your first equation, just like that, investment one, Brazilian plus Turkish equals, we want 300 kilograms. Now the next equation is how much each of these coffees cost. That's what you're gonna write as your next equation. How much is the Brazilian coffee a kilogram? 5. And how much is the Turkish coffee? 8. So 8T. And we want this mixture to cost $7. So $7 a kilogram. So how much would it totally cost right here? If you want 2,000 what?
100.
Yep. So what you have is two equations. You have B plus T equals 300, and you have 5B plus 8T equals 2,100. Okay, so now what do you think you're going to do to solve this? Multiply this by? So you have negative 5B minus 5T equals negative 1,500. Copy 5B plus 8T equals 2,100. And if you add down, what happens?
Supposed to say 5T.
This is, yeah, I multiplied everything by negative 5. And how many, what does T equal to? 200. So what does that mean? We have 200 kilograms of the Turkish coffee. So we have 200, we're going to interpret our answer, kilograms of the Turkish coffee, and which would make how many kilograms of the Brazilian? If you plug 200 here, what would you get? 100. Okay, so there's our answer for that. Now I want you to look at your homework for a second. And I'm just going to have you set up the first 3. We're not doing them, but I just want to set them up with you. I want to see if you see the pattern. So read number 1. There are 411 people at a play. Admission is $1 for adults and 75 cents for children. And the receipts for this, whatever it is, play, is $395.75. How many adults and how many children attended? So we've got 411 people consisting of adults and children. So can you give me the 2 equations?
A plus C equals 401.
Good. A plus C equals 411. And what would be the second equation?
1A
Good.
plus 0.75 or C equals 395.
Good job. And then you're going to solve those. We're not doing it now. Okay, read number 2. A chemist has one solution that's worth 80% and one that's worth 30% acid. How much of each solution is needed to make 200 liters of a solution that's 62%? So it's somewhere in between these two in strength. So we need 200 liters of the 2. So can you give me one equation?
A plus B. X plus Y.
Let's do x plus y equals
200.
200. And what would the next one be?
0.8x
0.8x
plus 0.31.
equals,
0.62.
good job. Okay, and number 3. We've got a nut shop and we need 10 kilograms of mixed cashews and pecans. And those mixed cashews and pecans are going to be $8.40 a kilogram. Cashews are $8 and pecans are $9. How many kilograms of the cashews and pecans do you have in this mixture to make this work? These are the
Okay,
two items we have,
so-
cashews and pecans.
C plus P equals 10 kilograms.
Yep.
And then 8C plus 9P equals 8.4.
Equals what?
8.4.
8.4 times
10 times
10. That's the total cost. If you
Yeah.
bought 10 kilograms at $8.40, it'd be $84. Are you getting this?
Mm-hmm.
Okay, good. Now go to the last story problem. Go to example 11. This one's a little different. This is a distance problem. Distance is equal to rate times time.
Yeah.
So, you're on your motorcycle, and you are going home. And you're going on your motorcycle at 45 miles per hour. You're traveling at 45 miles an hour, and then your motorcycle breaks down. Okay, so you gotta go 25 miles to get home. So you're on your motorcycle for how long? We don't know. Then your motorcycle breaks down, so then you leave your motorcycle and you walk home the rest of the way. How far do you have to go?
So rate divided by distance.
Well, we don't know. So we're gonna look at how fast that motorcyclist is walking, 6 miles an hour. And we know that the total distance is 25. Now, do I expect you to do this before I show you? No. But after I go over it, hopefully this makes sense and you'll be able to talk yourself through some of these distance equals rate times time. So here you are on your motorcycle. And you are going, you're traveling, I'm gonna draw a little visual here. And you're going at 45 miles per hour. And we don't know how long. So distance is equal to rate times time. And then it breaks down. And we walk. And how far do we walk? We don't know. But we're going 6 miles an hour. So this is motorcycle. And this is walking. At 6 miles an hour. Now, if the entire trip takes 2 hours, and we don't know how long we were on the motorcycle for, we call it T. How long did you walk for then? If this is T, how much of that time did we walk? 2 minus T. So whatever time it took for us that we were on the motorcycle, 2 minus that time will be how much time we were walking. And we know that the distance, this distance plus this distance is equal to what? We'll call that D1 and this D2. The distance on your motorcycle plus the distance on your bike is 25 miles. Because that's how long it is from here to here. So can I substitute this in here? So 45T plus 6 times 2 minus T equals 25. How will I solve this for time?
Oh, you're gonna distribute.
You're gonna distribute. 45T plus
12 minus
12
16.
minus 6T equals 25.
Put together like 20.
Okay, keep going.
So 39T plus 12 equals 25. So you put together that negative 16 and 25T.
Okay, and so what do you get for an answer?
3.
You get 1/3.
Oh, other way around.
You get 1/3.
Cool.
So now let's interpret. It says, how far did the motorcycle go before it broke down? So what are you solving for? D1. D1. So this T value is 1/3. So what is 45 times 1/3? It's 15. So he was on his motorcycle for 15 miles, it broke down, and then how far did he walk? 10. So the answer to how far did the motorcycle go before it broke down 15 miles, and he walked 10 miles. You get this? Okay, so, what I want you to do for the rest of the time is do all of the story problems. You're gonna have today and Monday to work on it. And Tuesday's gonna be your partner test on 2-1 and 2-3. And Wednesday's gonna be a review day, and Thursday's individual test. Okay?
It's rough.